Thank you very much, IBM, for your illuminating thoughts on sort of as a cloud provider. This is what you do. We're going to shift gear a little bit now and look into a little bit about the telco segment. And I'm going to give you and offer you the observations from myself that worked within telco business as a telco provider, telco vendor for the telco operators for basically all my life. I work in the cloud infrastructure at Ericsson, and we've been working on these type of cloud infrastructures for the cloud operators for well over 10 years here now. So I'm going to give you a little bit of a tour of the different requirements that we have within that area and what we're expecting from IPDK, cloud service providers, hardware and software providers in that field. So first of all, let's look into why are the telco requirements initially a bit different than what comes out of the enterprise or the cloud providers and other market areas. So the requirements we have in our business are stability. It needs to be always on. It needs to be cost-efficient solutions because they are basically pressed for continuously increasing the performance, the capacity, the characteristics, but they do have a flat income curve sort of on that one. So it's more connectivity and characteristics per dollar all the time. And the mobility aspect is a bit important here as well, and you know that for each and every G in the telco world, there is a more increasing needs on this mobility to suffice as well. And in that mobility, spectrum is the most expensive asset there is. And spectrum, to buy spectrum, you also sign on to that you get penalties if you're not covering a certain amount of population. So it's very, very important to fill the spectrum in the most efficient way here. On top of that, we have, let's say, 3 to 5 competitors, competing operators for each and every country. And that yields you around 800 different operators in a worldwide sense. And they are bound to follow their respective countries' laws and regulatory frameworks. So it's very different laws in many of those different countries if you come down to the nitty-gritty details. Although that most of the regulatory things comes from the old PTTs, with those laws of being able to control the traffic, being able to have good quality communication set up for the country. But what this means is that we very often in this business, we are at the technology forefront. We have very, very large scale operations. And those two together basically says that we have to limit the choice of mature technology, or in some shape and form standardized technology, so that we can deliver on the promises of the technology as well as cost aspects and characteristics. But what we see here is that continuously, when we have matured that type of technology, it is reused in many, many different other market segments. So we are in some way at the forefront, but on the other hand, we need to use more standardized mature technology in some aspects. So what does the telco operators by themselves ask for? Stability. It's the key of them all. Quality, backward compatibility, and long-term support. They ask for portability, and they ask for a modular stack. They are very, very afraid of getting locked in to a particular vendor in any segment whatsoever. So they will be asking for that you on the hardware layer, on the software layer for the infrastructure, on the software layer for the functions, and on the management layers, that they have a choice. and that they can mix and match those in some way. And that requires that there is good amount of standardization, and that also is bringing on that it takes time. They're asking for predictability in supply chains, deliverables, their solutions of these complex stacks that are put together, and doing that at a very large scale. So those type of predictabilities basically comes into play that there is a need for multiple suppliers in many different places. The characteristics also need to be predictable because there is a lot of different technical requirements for ultra low latency with 5G and those type of things that are manifesting itself. The availability 24/7, 365, and the latency that if you want to have a end-to-end communication path with a real-time conversation as we are having now, then you need to have low latency. Otherwise, you will be experiencing the lag that our youth don't really love today, but we know what that means in telco world. And lastly, there is a couple of different requirements on it needs to be an evolutionary change where we can have a gradual in-service migration from the existing solutions. There needs to be a more and more rapid telco feature development and deployment path. And there needs to be alignment with other industries so that we can have some sort of help of bearing the cost for the solutions. We can't do own solutions ourselves only. So when we go to the where are the operators now in their sort of development journey, because it is a journey, and here we need to be very, very cautious because there are many different operators and they are at different places in their journeys for sure. So they are transitioning from I would say physical equipment on owned separate platforms, hardware and software, into a VM world and into a cloud native technology world. But I would say the biggest change is now going into the cloud native world, which they are trying to learn what that means to manage it at scale. And this will take a couple of years. I put on a figure 5 here. Some will probably take 10 years to get there. Some will be majority cloud native in 5 years, but it will take time, considerable amount of time. They are providing early trials together with commercial cloud providers. They start with IT-like applications, OSS and BSS and those type of things. They are experimenting with more demanding applications here as well, but it will take quite a long time until that gets penetrated, good penetration for it. And they are trying to understand as we speak, how could you use hardware accelerator in a good way? What will be sort of the requirements on the rather small sets of critical applications that we have within the telco community that really requires hardware accelerator to run performant enough and cost efficient enough. And coming up now as well, power efficient enough. That is another one that is coming up on the horizon as a very, very important thing. But we at the same time have the problem statement that each and every combination of hardware and the software components that I talked about before in different layers, they need to be thoroughly tested to be able to get to the deployment at scale. And we're not deploying something that could fail every now and then, because then we're going to violate a lot of the different requirements of uptime and availability and all these kind of things. So it is very, very complex to bring in a hardware accelerator that needs a different set of hardware components or software components to go along with it, or different management components. And every technology shift in here is always driven as a slow and gradual migration. So basically technology adoption for telcos, it takes rather long time, and it always requires a smooth, gradual migration to be supported. So what does it take for the telco now to be able to go into using IPUs, DPUs, and even programmable switches here over time? There's a need for industry alignment without a lock-in from neither hardware, software, or cloud provider vendors in here. The telco network functions, as we talk about, which is rather complex functions. It's not like the router people are talking about. A router is a network function. Here we talk about that a packet gateway, which is basically taking traffic from the radio domain and putting it on internet, or the whole radio application in itself is one or two or maybe three network functions in itself, highly distributed in itself as well. So it's rather complex network functions. From them, we got to have a portability. And we need to be, for instance, having a way to ease the migration from the current SRIOV-based applications for these critical applications. And why do I say that we need to, in some way, migrate away from it? I mean, the SRIOV in itself is actually a problem child because it gives the application direct visibility down into the NIC vendor-specific stuff. And bringing on more vendors into different clouds that the operators build for themselves, or that the public cloud provider will provide to them, will increase that mess of need of different drivers in this area as well. So what we had a bit of a chat on the chat with some of the people talking yesterday was about sort of, can we have a better abstraction? Can we have an abstraction on the NICs that basically goes up to the level of, there is one driver needed for an IPU, DPU, and that's really the same, whether it's going to be from a public cloud provider or your home brewed cloud that you provide. So that's one of the areas here of essence. That whatever infrastructure acceleration that is brought to the table, that is transparent or invisible for the application layer, and invisible in all aspects, functionality and characteristics wise, at least for the characteristics that they care for. And when we show up some sort of a functionality up to the network functions application layer, then that should be in some shape and form standardized or at least aligned, so that the network function doesn't necessarily have to understand how it is placed in an environment that has a particular IPU or DPU, or even if the work is done somewhere else, maybe on a CPU or on a programmable switch. Then it also takes that there are supported softwares and supported solutions. And there are multiple different companies that will come providing these, and the operator in itself would normally use a system integration company. That could be one of the Ericssons of the world, or it could be somebody that is specializing in doing system integration, or for the tier one operator, they could really have it in-house themselves as well. And it could be different for different type of applications as well. But they all fall back, and we all fall back on that the basic software that is used in our Linux environments, in our virtualization environments, in our Kubernetes environments, and so on and so forth, have supported distributions in many, many different places in here as well. So that there is a support, and that goes back also to the long-term support that I talked about in the earlier slides. And all of this under an improved total cost of ownership. So it can't really start costing more to start using these devices. It needs to, on a total cost of ownership, it needs to cost less for each and every generation. So without these elements, what you will see from the telco environment is a number of sporadic trials for niche products and niche deployments of products. And that's probably not what we want to have. So the question from us is then, could IPDK help to support the telco requirements here in some way? And we think so. And the reason for us talking about IPDK is because we have started to talk in that community, and we haven't really seen what OPI is bringing yet, although we're rather excited about that. But IPDK should, or maybe must, supply the multi-vendor IPU, DPU for the telco operator. They will not buy something if it is not supported by at least 2 major vendors in the industry. And they need to be as reputable so that they can sort of stay in the game for enough time in here as well. Good. It needs to allow a mix of IPU, DPUs and CPU-based deployments, because we can't migrate overnight, and we can't require all deployments to have an IPU or a DPU. Like we were having a chat about that during the F5 discussion about if it is a sort of a revolution or an evolution. In our business, we cannot have a revolution just putting in IPU, DPUs everywhere. We would like to get to that point, but we know to get there, we need to have an evolutionary step to be able to get there. And we have to enable also the software stacks that we put on the IPU, DPU to have a large portability for us telco vendors, because we will not have the funding, the resources to be able to write a highly specialized telco stack for one vendor's IPU and another stack for the other vendor's CPU or DPU, and a third one for the CPU. So we need to have this portability in between vendors and target devices. And that is also the things that can enable us to have the portability in a very, very small edge deployment where we might not have an IPU or DPU because of maybe cost reasons or whatever. There might just be a CPU. Then we want the same code base to be usable on a regular type of a CPU, because the traffic amount might not be that much. In other places where there is an IPU, DPU, we should use that. But in even other places where we might have a programmable switch, there we can spread out the functionality and do some pre-classification, load balancing or whatever on the programmable switch, and do other things on the IPU, DPU, and yet third things on the CPU, without really changing the base code in the application as such. It needs also to enable the software applications to be portable when there is exposure up to the software application. And we, of course, hopes that these network devices that helps out with networking stuff. And telco suppliers, they are in the networking business. So everything we can do and offload from an application down into an IPU, DPU, or programmable switch, specifically offloaded down to the actual data plane. Everything we can do that is a gain for us. But if we need to have 2 code bases, if we need to have 2 testing, different test methodologies, or test system testing these ones, that sort of defeats the purpose. So we need to have the ability of the software application to be portable without the need for a heavy re-verification. And we need to fit the cloud native paradigm to be sort of seamlessly exposed into the Kubernetes infrastructure. And that, of course, needs to include everything that we in Telco, where we are on many aspects in the leading edge of Kubernetes usage, in terms of we need heavily to use things like secondary networking, because we deal with things on the network where we need to see through down into the network layers in itself. So we can't really have a flat layer 3 behind a NAT and look at the packets. We need to look into the raw packets on the line here when we are doing our stuff in there. So let's work together to grow a shared cake in here, instead of sort of chasing the small slices for each and every one of us. So last slide here, the call for action. Drive the DPDK to enable, IPDK, to drive the portability and the infrastructure, application and devices so that we get supported IPU, DPU. We get supported hardware OEM suppliers that can use these IPU, DPU. That we get supported OSV distributions that can be used inside those IPUs, DPUs, as well as that can be used on the host using those IPU, DPUs in the IPU, DPU layer. And lastly, the support by the cloud service provider that would be the same APIs for the applications as I talked about before, when you're using a cloud service provider, as if you would have built this yourself. And then, of course, we need to include this into the different telco standards, IT standards, and networking related standards as well, so that they will live for a long time and be backward compatible in the way we need. And lastly, then, the enable the IPU, DPU total cost of ownership to be the positive step for all the deployment cases, with the broad acceptance that is required to even start the initial software development in the telco business. So we have we need to wait for the tipping point when we see that the investment of software and test in this area actually pays off. And that can be a hard sell, specifically if we're chasing those small little pieces here and there. Those will not give us the over the initial hurdles in here. And we need then also at the latest point to enable the interaction with other hardware accelerators that we have in the business here, such as for the radio and those type of things. So let's engage together and grow the cake for the whole telco deployment segment as such. That's my last slide and opening for Q&A.
Thank you. So first off, I do want to let you know that Dan Daly is super excited to see the list, and he's going to create a Slack channel in the IPDK area to track it. So he says thank you. First question, even though there is a lot of complexity to manage to allow telcos to consume and deploy IPUs and DPUs at scale, do you see a strong appetite from telcos to deploy them for telco use cases?
I see a strong request for asking companies like ourselves and asking accelerator developers for how do you see the development of these type of accelerators and so on and so forth. I do not see a great demand for actually putting them into play into their network yet. So, I mean, I see a bright future, but a number of these hurdles that we talked about must be overcome before we can see a broader deployment.
Great. Next question, what are the most desirable applications you would like to offload entirely to an IPU or DPU?
None, I would say. I think offloading everything into a piece of silicon, that will not happen. The world is too complex. There are too many deployment cases. And there is, I mean, if there were one deployment case, like a Wi-Fi hotspot or something like that, you can build millions and millions and millions of those. But the market for the different type of radios, the different type of sizes of packet gateways and so on and so forth, it's so vast. So it's really not feasible to move them into one single device here. So I see that IPU DPUs is a very, very good building block that should very much focus on doing infrastructure acceleration for sort of the Linux, the Kubernetes area, the splitting up of different networks from each other, enabling the security parts, helping out with the infrastructure so it becomes sort of not as much pain with those things, but also enable a certain amount of proprietary acceleration offload to be done for our vital telco type of applications. And they would be things like radio. And there I don't think I'm talking about sort of the lower layer of the radio, because they will always be specialized. And I don't think any IPU, DPU developer will be qualified enough to be able to do a good one of those. That's maybe a challenge, but we'll see. But for the networking part, I'm very, very excited if we can sort of ride on your vast experience of the networking devices here, and we don't have to implement them ourselves. That would be a good thing. And also the packet gateways, or UPFs, they are sometimes called. It's packet forwarder of how you move data in between a radio domain and into an IP domain, or IETF, IEEE type of a domain and thing. But there is a lot of different things happening in that is highly complex, deep packet inspection, and a lot of different things happening in there. So also there's a need for sort of, how do you mix? And I think that goes to my last bullet in here, to enable the interaction with other hardware accelerators. And I'm pretty excited over a couple of different things I've seen in the industry of how you could connect something like an IPU DPU to another device over maybe a PCI or CXL bridge in some way, if that's a separate bridge or the root complex or whatever. But these type of things that enable sort of the best of those two worlds.
Great. We have time for one more question. I'll take them in order they came in. Are these Ericsson call to actions all key dependencies and must-haves, or do you see priorities that must be addressed across a short, medium, and long-term time frame?
Okay, if you go back and look at the slides later on, they are all sort of top to bottom prioritized, seen from the kiosks. So I would say getting to, the most important thing I think is getting to a place where the hardware providers of IPU DPUs work together to create something like IPDK, where I can have one interface of the application and infrastructure, both from a direct interaction as well as from the management point of view. I would say that that's the priority number one, because then we can start proving that the devices from the different manufacturers actually can be used with more or less the same base code and with minimum retesting done. And it's very, very similar to that we see in the industry now, that there is more and more requirements for can we run on some other main CPU than the one that we have used before, whatever that is. And that's different for different geographical areas. But they are asking for those abilities to be able to run on more different devices as sort of the first step of enablers. And for that to be viable, we need to have a portability as telco vendors, and the providers need to show that there is not too much of a difference in the different deployments.
So thank you, Thomas. Do want to call out, there's additional feedback and questions that are in the chat window, so encourage you to chat with people. We did get a comment from Daniel at Bell Canada that says, I am a telco and I do have the need, wish, and requirement. So
Happy to hear. I love to go
there
to
you
Canada.
go. So thank you very much. At this point,